Hello and welcome to my YouTube channel. In this video, I will walk you through my Python script which analyzes the NASA battery dataset to understand changes in battery impedance parameters over time. We will explore how the data is cleaned, processed and visualized using tools like pandas, plotly and datetime module. Let's start by importing necessary libraries like pandas for data manipulation, numpy for numerical computations, datetime for time parsing and plotly for interactive visualizations. Here, renders.default is equal to VS Code ensures that plotly plots display properly in VS Code. Now, I load the metadata file which contains important information such as file names, battery IDs, and start times for the dataset. Now, I filter only the rows where the type column equals impedance as we are specifying analyzing impedance data. File_df includes details for reading files while impedance_df contains the actual impedance parameters RE and RCT for visualization. The start time in the dataset is in a row format, so I define a function parseStartTime to convert it into a Python datetime object. The function splits the raw string into components like year, month, day, etc. and then reassembles them into a valid datetime object. If the format is incorrect, then log the error and return NAT, which stands for not a time. Next, I apply the parseStartTime function to clean the start time values in the impedance_df data frame. Then I remove any rows where the parsing failed and sort the data chronically. Now I loop through each unique battery ID to isolate data for each battery. This ensures that the visualizations are specific to each battery's impedance parameters. Using plotly, I create an interactive plot for each battery. The blue line represents RE values over time and the red line represents RCT values. Line plus makers mode shows both the line trends and individual data points. The update_layout method customizes the chart, adding titles and a legend for better readability and visualization. Next, we create the average impedance for each battery by processing individual data files. Each file is read and the battery impedance column is processed to extract real values and compute the mean. Finally, we plot the average impedance values over time for each battery. Thank you for watching. If you find this analysis insightful, do not forget to like, share and subscribe the YouTube channel. I look forward to hearing your thoughts in the comment section. Stay tuned for more excitement content.